All right, guys. Welcome once again to this amazing session. I am honored and humbled to be your host for this series of workshops. My name is Samba Otavis, founder CEO for Sonavis Tech, and I'm currently hosting this session from Cameroon. And I don't have a tech background per se. I transitioned into tech from a medical background, so I'm a trained medical doctor. But I was looking for an opportunity where I could be able to impact lives across the globe. And the greatest vehicle I could use was tech. And so I was very curious to go out there and search for information. And got so kind, I was introduced to cloud computing by a cousin of mine in the US. And I grasped the opportunity and made some sacrifices to study and succeed in the industry. One of the greatest things that helped me along the journey was the huge network that I began to build. Because coming from a very non-technical background, I knew that in order for me to succeed along the journey, I would need help from those who have gone ahead of me. So I had to connect with people. And it is in that same light that I knew so well that many people who are looking for such opportunities to transition or to sustain the industry, but probably they don't have the right network. And so I decided to see how we could come up with a platform like this where we could connect people to getting access to simplified trainings. And we started off with this series of free workshops in line with live boot camps that we organize. And so we've had several other sessions which, if you were not opportune to attend, you could be able to reference from our website. I think Eric will be able to drop the website in the chat, sonavistech.com. So you can be able to access our past recordings right there. And so in one of the sessions, we actually had a live training on provisioning a 3-tier architecture manually on AWS. And it was quite fascinating, and the feedback from the audience was so great. So we decided that it would be amazing to see how we can cut down on the length of time it took to provision that infrastructure and also bring in other best practices as used in the industry. That will be like using infrastructure as code. So that's the reason for which we decided to organize this particular session to see how we can be able to provision this infrastructure on AWS using code. And we decided to use a tool which is more cloud agnostic, which is Terraform, right? And so to be able to do this, I decided that it would be nice to have to connect with others who are in the industry and who have had some great experience, right? And equally, those who are growing through will be able to relate with that. So I reached out to Bisan, who has an amazing background as well, I think in engineering. And we're equally going to have Engineer Eddie here, who is a senior DevOps engineer in the US. They are going to be the ones to pilot the session of today. I'm just your host to coordinate, right? So I would want to plead on every one of us to be very, very attentive in this session, be very, very interactive, because an interactive session, right? So that we'll be able to get so much value out of this. Without much ado, I would want to let us welcome immensely in the chat. Just drop any comments in the chat to welcome Misan. Misan is joining all the way from Canada, and he is going to be taking us through the first phase of this particular workshop. Misan, if you can hear me, you have the mic, sir.
Oh, thank you very much, Doctor. Feels great to have this kind of opportunity to share learnings with great cloud enthusiasts. So just as been said, my name is Misan Kelvin Ikomi, and I've got a background actually in geology. I haven't been in the oil and gas sector for over 10 years. I was eager to actually look for something else that was more challenging and where I would actually be in the position to provide solutions to world problems. And somehow I got talking with individuals and I got introduced to cloud computing. I've been in cloud computing for a while now, and I'll tell you it's been a very promising and enjoying period. So for our session today, basically we're going to be talking on Terraform and how we can employ Terraform to get to design a complete 3-tier architecture. And just as been said, there's been a workshop previously where a 3-tier architecture was being built, but that was done over the console and manually. The whole essence for today's session is actually to get to understand the basics around Terraform, basic concepts around Terraform, and why use infrastructure as code instead of getting to do things manually. I could see here on the call, we have great enthusiasts. We have people from different parts of the world. In order not to take much of your time, I would want us to go straight because I have a presentation slide in which I intend to run through. I will quickly share my screen while we dwell on that. So please let me know if you could see my screen. Just drop a yes on the chat session, please. Okay, that's great. Thank you very much. So without much ado, like being said, we are here for the workshop on Terraform. So over the internet, and we could actually get to see a lot of talks on Terraform. And here we are this very day to get to study about Terraform and also get our hands dirty on Terraform. So for the purpose of today's session, we shall be running through, firstly, introduction to IAC, which is infrastructure as a code. We move further to understand what is Terraform. Follow up with getting to understand Terraform lifecycle and dwell on some useful Terraform concepts, then a summary. So introduction to infrastructure as code. So just as been said, we've had instances where I believe we might have tried to get to deploy infrastructure, the different infrastructure via the console. For example, you intend to deploy an EC2 instance, you intend to build a virtual private network, which is a VPC, and we get to do those manually in instances. But in real life scenario, there are situations where we could find ourselves where getting to do this manually could actually be so cumbersome. And not just cumbersome. For example, you are in a situation where your organization needs to have about 200 EC2 instances or more deployed and several VPCs deployed as well. And maybe you need to have these VPCs spared to have steady communication. When you do this manually, you could be in the position where you have to take notes, but somehow that could actually be prone to error. So that is where the concept of infrastructure as code comes into play. And basically what that has to do is getting to have templates written. And with those templates, you could actually get to deploy resources as much as possible with the different cloud providers, just with your codes, with a few commands. So basically, we have infrastructure as code, and the essence is actually the management of your infrastructure using code, just as been said. And also, it is simpler for us to get to manage the configuration of our infrastructure. Like I said also, it makes things faster and easier. If you want to deploy your infrastructure or get to build and design infrastructure, getting to do that manually, it takes a lot of time. And also what we try to do is that for efficiency, you want to be able to do a lot of tasks in a very short time. While you get to do that with infrastructure, you get to end up getting to reduce human errors, because humans are prone to errors. So for example, if I get to do something manually every day, complacency might come in. There are things I could feel I've actually done while I've actually not done them. But with infrastructure as a code, you actually will have a state file that you could fall back to, and you could actually get to do things with your codes that are being written within minutes. And also with infrastructure as code, you could be sure of a better security. And also if you have situations whereby your system is prone to disruption, you could use your codes and get back, up and running as easy as possible. So there are different infrastructure as code tools usually provided by the different cloud providers. So we have CloudFormation, we have Resource Manager by Azure, and also Deployment Manager. But why are we here to actually work and study Terraform? Because Terraform is cloud agnostic and can actually work with a large number or any cloud provider. So quickly, we would move to getting to understand what is Terraform. So Terraform is actually an infrastructure as code tool that we get to use to provision infrastructure in any cloud, and it is owned by HashiCorp. Basically, Terraform uses a language known as HashiCorp configuration language. So one thing that's worth knowing is you can actually get to write Terraform templates using maybe a notepad or any of the IDEs. But if you write a Terraform template with a notepad, you would definitely need any of the IDEs like VS Code, Atom, and PyCharm to actually get to run your code. In our instance today, we basically will be using the VS Code. So Terraform lifecycle. So what we see here is an acronym known as IVPAD, and it stands basically for init, validate, plan, apply, and destroy. So while we get to use Terraform very oftenly, these are Terraform codes that we will get to interact with very often. So init, what does that basically mean? So what that means, that is a command that gets to initialize a working directory in your Terraform configuration files. So if you have written a Terraform template, before you go ahead to get to execute a Terraform code, you need to do a Terraform init. Basically, what that does is that helps you to initialize your working directory before you go ahead with every other code that you intend to carry out. So Terraform validates. Terraform validate, what that helps us do is to help us to check and be sure that our configurations on our template are rightly written. So you have the Terraform plan. When you do the Terraform plan command, what happens is that it gives you a preview of the resources that you intend to execute eventually when the execution takes place. So that's usually, there are situations whereby some persons, or you could get to jump the validate action. But for me personally, I love to do the Terraform validate so that I am sure that whatever I intend, the configuration I intend to run is well written, and I will have 0 or less errors. Then we'll move on to the Terraform apply. This is the command that gets to execute the changes, what you intend to run, the resources you intend to deploy on your specified cloud provider. Then lastly, Terraform destroy. This command helps us to destroy the resources that we already must have deployed by the previous commands. So now we move on to useful Terraform concept. So firstly, we shall be looking at the state file. So when we say state file, we need to understand that previously I talked about when we deploy resources manually, you might be in a situation whereby you want to begin to write what you have done as you get to progress on your plan to deploy infrastructure on the cloud. But Terraform has a useful feature, which is actually known as the state file. So what the state file does is, the state file is actually created when we deploy infrastructure on Terraform. And that gets to help us save our configuration on a backend. More oftenly, if you get to deploy resources or infrastructure using Terraform on your system, what happens is that a state file is created for you in your local. But further, we will look at another concept that gets to talk about your remote backend. So I'll come back to variables, because variable is actually something I want us to dwell on a bit before we end this session. So after state file, I want to move now to remote backend. So what does that mean? Now we already have our state file, which gets to store our configuration in our local. But for example, if you are working in a team of, say, a group of developers, and you get to have your configurations done and you have your state file being saved in your local. So for example, I am developer A and I have my state file saved in my local. If other developers want to see the state of the different infrastructures which we have actually deployed at that point in time, it might be difficult getting to know where we are. But when you have a remote backend, it will be easy to access that remote backend and get to see our state file in that remote backend. So what a remote backend actually is getting to have your state file saved in a remote location. So usually that is done with the object storage for the different cloud providers. You could actually have your remote backend be Amazon S3 or maybe the Azure Blob Storage, and it is linked using the DynamoDB table, whereby you could actually now get to have your remote backend updated for every configuration action that you take. So that is why if you are working in a team of developers, you would more often be relying on a remote backend, whereby if you carry out any change on your infrastructure and your configuration, that will also be updated on your remote backend, whereby any developer in your team who gets to the remote backend will actually know the current state of your infrastructure that you must have deployed. So quickly, we look at what modules are. So modules is one of the concepts you have in Terraform that helps us better organized. So for example, if we are creating different files in Terraform and these files are unrelated, let me say you have something like an EC2, you have VPCs, you have RODS being created individually. You could actually get to run your code that way, but that way you have them a bit scattered. But what modules does for you is that it's a collection of configuration files in a dedicated directory. So if I am wanting to deploy a complete 3-tier architecture that involves EC2 instances, I could put my EC2 instances in a module. So everything concerning my EC2 instances, all the files concerning my EC2 instances could be placed in my EC2 module. So if I want to talk about networks like my VPC, my subnet, and the likes, I could actually create a module for my networks. So that is what modules actually are, and that is what they help us do. So quickly, we'll look at state lock. So state lock, it's a concept whereby you have the state of your configuration actually locked. Locking your configuration state is actually for a reason. So just like I said, if you are in a team working with other developers and you do not have state lock in place, what happens is if you have done a configuration and you have another developer somewhere else trying to do that same thing, you end up having conflicts in your code. But what happens with state lock, if, for example, you have a developer A working on making some configuration around EC2 instances, if another developer who is developer B somewhere else in a different part of the world is trying to carry out same action on that same configuration template, what happens is that state is locked and that actually cannot take place. So that being said, we'll go back now to variables. And we'll dwell on why we need to have variables. So variables basically is a file dedicated to help us get to keep sensitive information in our code. For example, while you get to make your template for configuration, there are certain sensitive information you don't want to be out there and easily accessible. And also there are certain information you know that you will use very often. Instead of getting to call them manually, you can eventually create a file where you have to make them variables and get to call them back at any point in time when you need them. So there are different forms. Variables could actually be in form of strings. It could be lists, it could be maps, it could be Boolean, and also it could be list of strings, or, and it could actually be a list, a map of list as well. So that being said, we'll move quickly to a summary. So basically, Terraform is an infrastructure as code tool that gets to help us deploy resources in cloud, but this time in any cloud because it is cloud agnostic. And also it's a useful tool for most DevOps team all over the world because it helps us get to do version control when you send your codes into a repository. That we would actually get to do while we get into Anson. And also Terraform is easy to use and secured. Thank you. So if there are questions, we could begin to bring questions. And while we do that, we have a few morphemes here for us to just have for refreshment before we get to have our hands dirty. Thank you.
Thank you very much, Misan. Great. So let's appreciate Misan in the chat. Can we appreciate Misan in the chat for that comprehensive overview of Terraform? And if you do have any questions, kindly raise your hand. Kindly raise your hand so we can have your questions. The first segment of this training was to talk about the theory before we get our hands dirty in the practice. So yes, we had this session prepared between three of us, myself, Misan, and Eddie from the US. And this workshop series on Terraform theoretical architecture was designed to be in two phases. So what we're going to have today is going to be a simplified version of a possible more enhanced version, which is going to come sometime in the future. So I'm going to pass it over to Eddie right now. Eddie, you have the mic, please.
All right, thank you, Doc. Thank you very much, and thank you, Misan. Hello, everyone. It's good that we're here today. And okay, yeah, that was a great presentation. And before I probably say anything, I'm just curious if someone here is probably already using Terraform somewhere and just wish to enhance the skill, or somebody is probably using CloudFormation or any infrastructure as a code tool, or everybody is still in the process of trying to get equipped with these tools. Is there anybody using it already, like in the field, and just probably needs additional knowledge, or maybe using another one that is not Terraform? Just curious. If you do, you can just put up your hand. I don't want to put you on the spot. I just want to know. Okay. All right. That's interesting. Now that was great, and the presentation was flawless. I just want to say, as Misan is presenting and going, there are things that he made mention of which you might want to jot down somewhere, because when the hands-on starts, that's very, very important. One of the most important things in Terraform is the state file that he mentioned, because state files are very critical in Terraform, and they are editable, meaning if state file shows the backend of your configuration, but you can actually write into a state file, which means if it is a file that you want to avoid as much as possible, which is why he made mention of a state log. So that's something you might want to put down, and you might want to research on that again, even after this workshop. And what we are trying to gain here today is to make sure that you minimize your code as possible. A good code should not be duplicated. But today you are going to see us duplicating code. But best practice, that's why Doc made mention of the fact that it will be in 2 phases. So today we are going to take you on how we have infrastructure as code, but it's going to be as ordinary, if that's the word, as it can be. But the next session that we'll be having, we'll try to make it more enhanced as per industry best practice, because duplication of code is something that is not very, very popular in the industry. Somebody made mention of in the chat that can we explain the concept of DynamoDB? DynamoDB is basically like a database that is not it's not structured. You know, you deal with keys and values. I think Misan will also go into that when he starts with the hands-on. So like I made mention of state file being very important. So what happens is when you create your state file, you create a DynamoDB, which creates a log ID, and you lock that state file. Simply put, it means if I'm working on this environment, nobody else can use this environment, to avoid multiple people using the same state file. But DynamoDB is basically a non-relational database. I'm sure you'll go into that as he's doing the hands-on. But there, you need to have questions at this preliminary stage. Like, you need to ask questions. For what he said, we need to discuss so that we know the level at which we are. You know, we need to be interactive. So I'm expecting more questions at this discussion phase before we get into the hands-on. He made mention of a lot of things. He made mention of a lot of things. The basics of Terraform. Do you know it, or is this like your very first session in Terraform? So I'm expecting that we should have about 15 minutes of interaction where everybody, or at least everybody, should have something to ask so that we know where we are going to after this. Thank you.
Thank you very much, Eddie. And yeah, okay, Eric, you have the mic, please. Thank you.
Yeah, hello.
Yes, Eric, we can hear you.
Yes, yeah. So my name is Eric, and I'm sorry, I'm from Ghana. So please, Misan, I want to know, aside Terraform, is there any other infrastructure as code tool that we have to know?
Okay, thank you very much, Eric. So there are so many infrastructure as code tools. Each and most of the cloud service providers, like the AWS, has CloudFormation. You have the resource manager as well from Azure, as well as the one for GCP. So basically, you could get to do learnings on the different ones, depending on what your interest lies on. But the intriguing thing about Terraform is if you understand Terraform, you could actually get to use Terraform with the different cloud service providers. So in recent times, there are trends of organizations why rely on the infrastructure as code tool your service provider uses, when you can actually get to rely on Terraform. And if for any reason in the future, you intend to switch from one service provider to another service provider, and your organization already uses an infrastructure as code tool, which is Terraform, it will be very seamless for you to transition from one service provider to another service provider. But if you were stuck using something like, say, CloudFormation, basically on the AWS platform, and for some reasons, you are switching from AWS to another cloud service provider, you try at that point, you find yourself in a situation whereby you need to get to understand how the infrastructure as code tool for that service provider works. So that is why Terraform is cloud agnostic, and it's something worth learning.
Yeah, thank you very much.
Okay, anyone else has a question? Kindly indicate so we can have those questions for the next 15 minutes. Okay, so silence means probably the initial phase of the presentation was very, very, very explicit. All right, so thank you all. I think
Sorry.
we can get, okay.
Hello.
Taiwo,
I just
okay.
have a question, please. Is it possible are we going to be having access to the recorded video? Because I joined a little bit late, and so that's why I couldn't ask much questions.
Yes, absolutely. We're going to have access to this recording.
Thank you.
You're welcome. Any other questions?
And I just also wish to add to what Eric said, that even AWS and Azure, they are doing everything to bring in Terraform, to incorporate Terraform into their services. Like because they know how powerful Terraform, they know that Terraform is the best infrastructure as a code tool out there. So they're doing everything possible to make sure that their service incorporate Terraform into it, so that many people will stop using Terraform. The same thing for Azure. That's just to show you how powerful and dynamic Terraform is. And even when you start coding, you will see that Terraform just takes coding to another level. The most powerful tool in CloudFormation, which is AWS native tool, is parameters, for instance. But Terraform has variables, like Nissan talked about, that you look at it, but still has a very powerful tool, which is called modules, and that is what makes Terraform a game changer. The fact that with Terraform you can use modules, and when you see the other cloud platforms, they have their version of modules, like CloudFormation has modules, but it is not that dynamic as Terraform is. Meaning, if you're in an environment or if you're on an interview and they are asking you why you prefer Terraform than AWS, you will see that Terraform has this concept of modules, which is a game changer. And in Terraform, again, we have what is called Terraform Cloud, which takes Terraform again to another level. Because with Terraform Cloud, you don't need to be running all those Terraform init, Terraform plan that you saw previously in your local. You have a Terraform Cloud, which means if on this call we are in the same industry and you are trying to create an infrastructure, I'm able to log into Terraform Cloud and see what you are doing. If we're working on the same project, you are not to walk in your local and probably tell me that, okay, this is what I did. You have a central view of what everybody is doing. So Terraform has a lot of features which you will see that just makes it much more dynamic than AWS. Now, there's a question in the chat that what is the difference between Terraform and Ansible? Now, Terraform is an infrastructure as code tool. Ansible is a configuration tool. Now, meaning with Terraform, you are creating an infrastructure. With Ansible, you are doing configuration changes. For instance, let's say you want to do deployment. Let's say you want to do patches. That is where you use Ansible to do those things, configuration, like patches and updates and all the rest. Terraform, which is an infrastructure as code tool, creates you that infrastructure. Now, having said that, Ansible can create you an infrastructure, but that is when you take Ansible from Ansible to Ansible Tower. Because Ansible Tower now has tools that can create you infrastructure, has tools that can bring about security compliance, which is still under Ansible, has tools that can also makes deployment for you. But Ansible, like static inventory or dynamic, that is for configuration changes. Meaning you have your servers, you want to run playbooks on your servers to maybe update your servers, to maybe make some deployment using Kubernetes and all. That is when you use Ansible. But Terraform is to make sure that you have that infrastructure in place so that you can use Ansible to carry out configuration changes on that infrastructure, if that makes sense. I don't know if the person that asked the question, is it okay, or if you can ask again. Doug, it seems like many people are probably putting a lot of their question in the chat,
so,
maybe.
Yeah, let me just, on that same question, which Eddie responded to, on the difference between Terraform and Ansible. So in a layman's language, what that means is, for example, you need to build a house. Now, Terraform would help you build that house. Now, that's basically your infrastructure in cloud already being built by the codes you developed using Terraform. However, in Terraform or in your house, you intend to carry out certain actions. For example, you intend to move your refrigerator from the kitchen towards the dining. And for example, you intend to install your television on the wall rather than being on your shelf. So what will help you do that? Ansible would actually help you do those configurations in the way and manner with which you want them while interacting with your resources or your infrastructure already deployed in cloud. So that's what it's like in a layman's language.
100%. Thank you very much, Eddie and Bisan, for that amazing explanation. Let me see the chat. What are the common pitfalls or errors encountered while using Terraform, and how can they be mitigated? That's another question from Francis.
Okay, like just like any infrastructure, and that's the beauty of infrastructure as code. You get your errors during runtime. Like Nisan made mention of init plan. Terraform plan, for instance, is to make you see how your infrastructure is, and if there is any error, you will see it at that runtime. You know, it can only be mitigated by you going and trying to troubleshoot your code. And that is the beauty, again, I would say, of Terraform. Terraform plan is like giving you, this is what you will see when you deploy. If there is any form of error, you will see it during that time. And troubleshooting is a very powerful tool in the industry and as far as coding is concerned. But one thing which is good is by the time your code successfully deploys, you know that your code has deployed what you want your code to deploy, because and with coding, if anything doesn't make sense, if you use the wrong AMI, if anything is wrong, there is no way your code will succeed, which is why infrastructure as code is very powerful. Having errors during coding is, permit me say, it's the fun of it. And it can be mitigated just by you troubleshooting them. When you have an error, you should be flexible enough to use Google. You should be flexible enough, develop the habit of reading over your code to read the error and try to troubleshoot before you deploy, as opposed to the console where you can actually click a wrong thing and it builds, which is why most companies prefer to use infrastructure as code, because with that, you get your error during Terraform plan, which means if anything is wrong with your infrastructure, you will see it during Terraform plan. You will fix it, you will run Terraform plan again, you will see if it has been fixed. If there's another one, you run again, you see if it has been fixed. By the time Terraform plan is good, that means your infrastructure reflects what you will see when you build. So by the time you're building, it's almost what we call like a definition of done. You know that, okay, my infrastructure will deploy. And there are times you will deploy and it will still fail in your local. You will still need to troubleshoot that before you finally deploy. So the moment you are deploying to cloud, the moment it deploys, that means there is no error. And you can now deploy that same code anywhere with confidence because you know that your code base has no error in it. The only way you can mitigate errors during coding is by troubleshooting. There will always be error. You know, I don't care how savage you are in coding, you will always have errors. But it's how you troubleshoot those errors that makes you a good coder, so to speak. It's how you are able to look for solutions. You are able to read and interpret the errors you have in your code. You know, Misan, I don't know if you have anything to add to that as well.
Okay, thank you very much, Eddie. So just to make put some more lights on that. So while you build your template on Terraform, it is advisable that you get to build your template iteratively. So for example, if I intend to build my templates and I intend to deploy, say, 10 infrastructure, it is advisable when I build one, I get to try my code to be sure it is running and passing. Then I could move further to the second one and try to develop and work on that. Reason being that When you wait until you build all your templates and you have them run, you begin to have multiple error messages that if you want to debug or try to troubleshoot, you find it difficult. But for example, if I intend to build, say, an EC2 instance, and I have that done, and I try my code and I have an error, on my error message, it will give me and tell me the line where I have that error message, and I can quickly have it fixed. And I move further to the next infrastructure I need to work upon. So that is one of the good practices, best practices that's actually good while you get to build your templates. Other than that, if you talk about most of the errors you get to encounter, firstly is when you run Terraform init. So when you run Terraform init, as much as it is trying to initialize a directory for you, what it does is it sends an API call to the cloud service provider to have that connection. So for example, if I am running Terraform and I intend to use my provider as being AWS, and I intend to run my infrastructure being deployed in a particular AWS account, if I have that API call not going through, those are the kinds of error you begin to encounter from the beginning. Other than that, other kind of errors you can begin to encounter are authentication errors. So for example, if I don't have access to an account and I run a Terraform template and I intend to have that Terraform template deploy resources in an account where I don't have access into, it would not work. It will begin to give me error messages. So your authentication into a particular account, regardless of what service provider you're working with, needs to be top-notch. So if you are working with, say, AWS, your authentication with that particular account on AWS you are working with needs to be top-notch. Same applies to Azure, same applies to GCP, same applies to Oracle and other cloud service providers. Then that being said, when we move to Terraform Plan, or rather Terraform Validate, when you do validate, if your configuration is actually right, it will give you a message saying your configuration is good and it's okay. But if it says your configuration is not okay, an error message will be given on to you, which will tell you the line on your template where you are having that problem coming from. You could actually now go back to your template, try and see what the error message says, and eventually try to have that fixed. Other than that, when you try to execute your apply code, the kind of error messages you could actually still get are if you've built your template not following the guide as stated on the documentation template. So for each of the cloud service provider, just like for AWS, you have like a documentation template that you rely on while you intend to create certain resources. So for example, on AWS, if I want to create an EC2 instance, I don't just create that over my head. I go back to what the documentation says. And to do that, what you now get to do is you understand what the business requirement entails. So if you intend to create an EC2 instance with an EBS attached, what you do is you check what the documentation for that says, the argument reference says, and you get to apply that. As we get on and begin to get our hands dirty, we would begin to encounter some of such and also try to troubleshoot and have them resolved. I think that throws more light on that. Thank you.
Thank you very much, Misan. We have another question in the chat that says, how can we secure our code?
Based on like experience in the industry, every company has a remote repository, like Misan talked about, like GitHub, GitLab. That's where you store things like code. If you've heard of repository, in an organization, everything that you will be using that everybody will need to contribute to is stored in a repository. So each time you probably need to make changes to the code, you have to clone that repository in your local. You've heard of branching and things like that. I'm sure maybe in the product, that's the flow that is in the industry as well. You have like a repository is just like a warehouse in your company where everything that has to do with the company with respect to coding and everything that everybody would need to contribute to is stored there. Then each time you need to use it, you clone it. If you create a new one, that will need to be used in the organization as well, you push it to that repository. We have GitLab, we have GitHub, we have Bitbucket. You know, we have there are a lot of tools out there that you use to store your code. Remember, you cannot store your except it's for your own personal use, but you cannot store. We are talking here about at the level of organization. You cannot store an organizational material like coding in your local. It has to be in a remote repository where everybody can see, everybody can contribute to the code to make it better, and everybody can equally clone the code to make changes or whatever is needed.
Thank you. Thank you.
Okay, so
Thank
let me
you.
just say something on that as well. So Eddie, thank you. So having a repository, aside the one that could be used collectively, maybe for an organization, there are repository that you could actually have for your individual use. So for example, I have a GitHub account and I have my code being built in that account. If I want public access to that repo, I could actually make it public. But if it's something I don't want the public to have access to, and I want access controlled on that particular repository, that's now left to me to give access to that repo to whoever I want having access to my codes. Thank you.
Thank you very much, Misan, for adding more to that. So the next question from Francis: how does Terraform handle sensitive data or secrets?
That's to answer that. When you go into parameterizing, or in Terraform, like they call it, variables, you will see, or modules, you will see that you don't even actually have to hard code anything. And things like sensitive data in every organization have their best practice as to where it is stored. So we have the concept of modules in Terraform, where all you need to do is just pass skeletons, like, permit me use that word, skeletons. Anybody that needs to use that skeleton will now put the flesh, which means, for instance, if I need to get into an RDS instance, for instance, you don't need to hard code everything that I need to get into an RDS instance, like the host name and all of that. You just verbalize them, you create variables. I might need to get into or create an EC2 instance with T2 micro, and somebody wants to create with T2 large, but we are using the same code base, which is the module. So with sensitive data, every organization have their best practice. Some will be in S3 and they have, you hear the concept of least privilege. Maybe just the administrators, they have access to that sensitive data, because sensitive data is very important. But then again, if there is a code that is supposed to consume that sensitive data, they will never hard code, which is the advantage of us using Terraform now. If you need to use, sometimes you just need to run that code, and there's an API call to authenticate into the account and pick the sensitive data from wherever it is. Maybe like in AWS, we have Secret Manager. That's where you store secrets that you don't want anybody to have access to. We have Secret Manager. You can even store in parameter store, but the difference is that the secret in parameter stores are not encrypted. You can actually see the secrets, but in Secret Manager, they are encrypted and they rotate, which means you can set your secret in Secret Manager that after 30 days, I want this password to change and stuff like that. So sensitive data, you don't need to hard code them into your Terraform script. There are places that you will store them, but you have mechanisms in your Terraform scripts that when they run, they are able to pick those secrets and do whatever they want to do. Let's take, for instance, you want to authenticate into database. You need a password to authenticate into your RDS instance. You don't need to create your Terraform code with those secrets hard-coded in it, but your logic, the code logic to authenticate into RDS instances will be in your Terraform, but the secrets will be in parameter store or secret manager. The moment you trigger that pipeline or you deploy that code, it has that intelligence again through API call, like Nissan said, to authenticate into the account, grab the secrets from AWS, and get into your database. So when it comes to secrets, never you hard code your secret into your code. Let me give you a colleague of mine that was in October was fired. Why? Because he needed to send credentials to someone and he emailed those credentials. He emailed those credentials encrypted, but he was fired because our company has its policy to send secret. That is to tell you how what's the word, for lack of a better word, like how delicate secrets are. So secrets are something that you can be working in an industry, but you will never see secrets because special people, a group of people have access to it. It is stored somewhere. It is encrypted. You are a cloud engineer. You are working on Terraform. You don't care about what the secrets are, but your code logic, when you deploy, it has the intelligence to make that API call and grab the secrets and deploy. So I don't know if that answers it. You don't have to bother about putting secrets in your Terraform code. Create the logic to be able to grab the secret and authenticate to do whatever you want to do in your environment.
Thank you very much, Eddie. Can Terraform be used to provision on-premise infrastructure? From Francis again.
Misan, will you want to answer that? Maybe take that.
Yes, Terraform can actually be used to provision on-premise infrastructure as well, but that's not so famous and not something I've actually gotten myself abreast with.
Yes, like the previous question somebody asked about Ansible. Most on-premise infrastructure that I've come across, they prefer using Ansible for their infrastructure because Ansible is very friendly on-prem. So on-prem, they prefer using like Ansible to do their for provisioning of their infrastructure. I remember I talked about Ansible Tower. You know, the hybrid environment that I was on, they are on-prem. They use Ansible for provisioning of their infrastructure. But Terraform, I've never seen a case where it is being used on-prem, but that is not to say probably it is not used on-prem. That would just probably be something we probably need to research on, or you can equally research on. But as an experience, I have not come across Terraform being used on-prem, but I've come across Ansible more likely being used on-prem for provisioning of infrastructure. But that was a great question, though. That was a very good question.
Thank you. So we are exactly 15 minutes into the question and answer session. Without much ado, I think it would be amazing we get a break. And after the break, we're going to come back for the hands-on. We have to get our hands dirty. So what are the prerequisites? You kindly sign into your AWS account. But before we go into that, I would want to suggest that we immortalize the day by grabbing a picture of the screen. We just get a screenshot. So please, let's all come on screen. Just kindly come on screen so that we can grasp a screenshot of everyone. Briefly, thank you, Wanye. Welcome. Good to have you. Miss J, good to have you. Anytime, good to have you. Linda, good to have you. Ademola, good to have you. Let's all be on camera so we can. Great. Wale, good to have you. All right. If it's possible to be on camera, that would be amazing. Emmanuel, good. All right. Let's have many more people come on camera so we can get this done, and then we can take a 10 minutes break. Then we come back for the hands-on. All right. Thank you, Folake. Thank you, Ate. Great. So, Yon, welcome. So please kindly wear your best smile, right? Wear your best smile as we grab the screenshot at the count of 3. 0, 1, 2, 3. Perfect. So I'm going to read it once again on next screen. So if you don't mind, kindly wear your best smile. Thank you, Olufem. At the count of 3, we do it once again. 0, 1, 2, 3. Perfect. So the reason we're getting this also, remember, in the industry, many people only focus on the hard skills, but the soft skills is actually underrated. So you also want to document this on your LinkedIn profile. You want to share on your LinkedIn profile for other people to see that you're also into continuous learning and growth, right? That's why we're taking these pictures. Right, so I'm going to grasp another one again. Let me see. I just get this on the spot. All right, so once again, great. So I grab this. Perfect. All right, guys. It's 5:05 p.m. my time. Let's return at 5:20 my time. Thank you very much. Grab a glass of water. All right, welcome back, everyone. Welcome, welcome, welcome. If you're back, just kindly drop a yes in the chat. Let's have a series of yes in the chat. Just drop a yes, 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 yes. Are you excited to be here? Are you excited about the session? I'm so excited. This is how we're starting our 2024. It's so exciting that we are starting off with projects. We have a couple of persons here who have been able to earn some certifications. The market has been slow for a while now on hiring, but then we are excited as we are getting to 2024 because thanks to these live hands-on projects, a lot of people will be able to go into those interviews, be able to articulate their skill sets, be able to articulate what they understand. And that's how, from this community, we're going to be celebrating so many people who have gotten jobs. I can't wait to see people testify on LinkedIn. I can't wait to see people testify on other platforms that it's thanks to these workshops, it's thanks to the networking that they had here that they were able to land those jobs, and not only land the jobs, but they were able to sustain the jobs, right? Because in this industry, it's all about collaboration, collaboration, collaboration. You don't want to be a one-man island. No matter how much you know, no matter how skilled you are, maybe technically, you would at some point need assistance from other people. And that's the reason why we decided to bring up this SolarBase Tech platform to be able to connect people. And we're doing this right from Africa. Ladies and gentlemen, I'm so excited. Why? Because of what's happening. IT is the future and IT is now. You want to do everything possible to get into this industry. You want to do everything possible to be able to connect with those who are already succeeding in the industry. And you want to do everything possible to give out your best. Whatever you know, however you know it, you want to have people know what you know. Sometimes it's said that it's not about what you know, but it's about who you know, and equally who knows you, right? It's not only about what you know, but it's also about who you know and also about who knows you. If you're so good at Terraform, if you're so good at DevOps practices, if you're so good at AWS or Azure, but nobody knows what you know, you could be stranded at your own end, right? But imagine you're in this community and, for example, there's someone here who knows about what you know and can be able to connect to opportunities. That's how we're going to rise by lifting each other. So the second phase of this workshop definitely is to have our hands dirty on the practice. And this session will be led for us again by Misan. Misan will take out the first segment of this. And in our subsequent workshop where we're going to enhance this project, probably Engineer Eddie will come in to get our hands dirty on how we can optimize the Terraform code, right? Following great industry practice. So today is going to be the scaled down version of the final project itself. And also just to let us know, guys, that while SolarBase Tech, we're running this trainings, these free trainings, we equally have boot camps that run for 6 to 7 months, hands-on practice-based. And also, I'm currently running a mentorship program for those who probably have attended other boot camps, but they're looking for post-boot camp sessions where they can be able to connect with other industry experts. I have a team of engineers in the field with whom we collaborate and we help people to be able to stay consistent while they look for those jobs, right? And in my mentorship team, we equally have people like Engineer Eddie and Emmanuel, a couple of them, right, who may not be here right now. So those who earn the mentorship, right, are able to follow through with us, and it's a mentorship for life. So you have some people that you constantly work with every week, and right on this call, we have some of our mentees, all right? So guys, those are some of the things that we have, and as we go on, you can always reach out to us through the same address that you're able to reach out to, either through our website, and as we go on, we're going to drop a WhatsApp link. For those who are not yet in our WhatsApp group where we share information about the, so we're going to have access to the WhatsApp group, those who are not in the WhatsApp group for the free workshops where we constantly give updates, all right? So for the mentorship program, you can actually reach out to me, all right? So you're going to have my contact in the WhatsApp group. Eric is going to drop my WhatsApp contact. You can actually ping me on WhatsApp and we're going to have a conversation. Those who earn the mentorship, because it's actually very, very robust, those who earn the mentorship will be able to have conversations on that and move forward. Thank you very much, and I'm going to pass it over to Misan once again. Misan, if you can hear me, over to you, sir.
Yeah, thank you very much, Doc Samba. And welcome back, everyone. I believe we had and we did enjoy our break. So quickly, without wasting much time, we need to get on the console first while we go ahead to have our infrastructure being built. So I believe we are all logged on the console.
Can you make your terminal a little bit bigger so I can? Okay, cool. All right, so now we are going to run your git clone command to clone your repository on this instance. So before we do that, you have to install git. So type the command. First,
we need to, yeah. Okay, sorry guys, please let's have our mic muted so we don't get to interfere with the call. So like I was saying, let's just get on the console, get signed in. And the reason being that, we need to actually understand something. For you who get to use AWS very often, if you intend to run an architecture on a program that you're not so conversant with, what you try as much as possible is get on the console, try to understand what happens with that resource around the console, so that when you are about to build your template, you have an understanding of what each and every line you are calling on the template, what that's actually going to do for you. So to have that done, we are going to create, first of all, a directory, and let's have that directory created on our desktop. So I would quickly share my screen so we do that collectively. So kindly confirm you can actually see my screen. If you can see my screen, just drop a yes on the chat session, please. All right, thank you. So quickly, let's have a folder created on our desktop. And let's get to name that Terraform. Three-tier architecture, in brackets, Solaris. So have we all done that? If we've done that, let's drop a yes on the chat so we move ahead. Yeah, hello guys. Have we done that? So we move ahead. Have we been able to create the folder on our desktops? All right. That's good. So that being done, can we now quickly open our VS Code? Let us open our VS Code. Let us open our VS Code. So confirm you could actually see my VS Code, and so we go ahead and call that hello guys, let's try and make this very interactive so we are all in one piece. All right. So if you are all there and you could see my VS Code, let's click on File and go down to Open Folder. So click on Open Folder. And now we are going to the location where we have that folder, which happens to be our desktop. So what we can do is to look for that folder on our desktop, the folder we just created. And here I have mine, Terraform Three-Tier Architecture Solaris. So kindly click on that and click on Select Folder. So we can now see that on our VS Code, we are on the Terraform Three-Tier Architecture Solaris. You would be seeing this message that just popped up. Kindly just click on yes, I trust the author. So if we're all at this point, drop a yes so we go ahead and begin to create our templates for the purpose of today's learning. All right, so that's fine. So here we are on the Terraform 3-tier architecture folder. The aim of this is whatever file we intend to create for the purpose of the architecture today, we want it inside this folder. So what we intend to do is, first of all, click on this. When you click on this, you have some options down here. The very first option says new file. The second option says new folder. So we are clicking on the first option because the very first thing we need to do, we need to ascertain and define the provider with which we intend to use Terraform to deploy resources in their environment. So that being said, let's kindly click on new file. And for this file, we are going to name this file provider.tf. So come outside the naming point and you could just click on that. So we have our provider.tf file created already. And herein, we are going to make a template containing the configuration for the provider we intend to use for today's purpose. So now we intend to use AWS, and Terraform has a documentation, and that documentation we can easily source for that and get the details we want. So to get that, I'll quickly go on my browser. And on my browser, confirm you can actually see my browser, please. So I'm sure everyone is carried. Okay. No, let me just bring that this way.
And please, is everybody at this level, or is somebody having any difficulty? You speak up, or is Nissan a bit fast, or if you have issues that you probably want to troubleshoot, you don't stay silent, please. You speak up. If you can't speak, you drop in the chat.
So on the browser, yeah, thank you very much, Eddie, for that. So on your browser, you could type Terraform AWS provider. That will actually take us to the documentation for Okay, Eric, is there any reason as to why you would rely on the recorded video and not follow the class? Let's just know what your challenge is.
Yeah. Sorry, my account has been how do you call it, suspended by AWS, so I'm trying to resolve that issue.
Okay, no problem. I thought it was something we can actually render help on the spot. Okay, so quickly, let's on the browser search for Terraform AWS provider, and that takes us to a documentation. So on that, I would quickly open that in another browser and let's see what's in there. So here is the documentation for the provider on AWS. And you could see on the right-hand side of this documentation, there is an example usage. There is a guide on authentication and configuration. There is a guide on AWS configuration reference. So for whatever use case we find ourselves, this is where we can easily get to find help. So at this point, let us just click on example usage, and it will take us to what we intend to have. So now we intend to have our provider being AWS. And for the purpose of our activity today, we'll stick with the US East one so that we are all on the same page, because we might be needing an AMI from that particular region. So US East 1, which happens to be the North Virginia region for AWS. So let us kindly copy this. I will drop it on the chat as well. Let's just copy this. So let's copy that and take that back to our VS Code and have it pasted. So you could see at this point, okay, we have someone's hand raised up. So please go ahead and ask what you intend to ask, please.
Yeah, hello, good evening. So I wanted to make an addition with respect to the documentation that we'll be using. I don't know if it is possible for us to probably have it on a side note so that we that will be going through the video later on, we can just have the notes, just like you started with the provider for the project, so that as we are working on it with the video, we can just have those notes at the right side, and we can just be copying it and using it.
Okay, so the best thing would be on you understanding how to get a source for this documentation online, because this documentation could actually apply to the resource that we intend to deploy at the moment. So when you now intend to deploy a resource which actually does not fall into what we intend to do today, if you don't know how to source for that resource from the documentation on your own, you might find yourself in a fix. So it's just straightforward. When you go on a browser, you can just search for that. Ensure you put Terraform. AWS happens to be the provider. If you were working with another provider, all you needed to do was to put the name for that provider, you know? So as we get on to use this, you will understand how to get what you need on the documentation. I hope that gets to answer your question. So
Yeah,
let's move on. Oh yeah, so let's move on. If we have that copied and pasted, put your cursors here and hit enter. So we add like a profile. So I'll get to explain each of these lines. So at this point, it's stated here, the provider, and we've gotten to give the provider as being AWS. You have a starting curly, open curly bracket here and a closing curly bracket. So for every of these, you should have a closing curly bracket eventually. Now the region, we have specified the US East 1 as the region for the purpose today, and the profile is being default. Even this profile, if you don't put a line that says profile, and you get to remove this default, it will automatically get to work with the default profile on that account. But you stating a profile here explicitly, if you have other profiles other than the default profile being created, you would have as well just fixed that in. So this is our provider.tf file here created. So we'll move quickly to create another file, which happens to be the ec2.tf. So now let's leave this portion. Let's come back to the Terraform folder and click on it. Then we click on a new file and kindly name that new file ec2.tf. So if we've done that, you could see we have a new file here open for us. So if that's been done on your end, kindly drop a yes on the chat so we know we are all on the same page. Okay, great. Great. So now we perform a similar action. What we do at this point in time is we now go to the documentation. I'll close this and we'll go back to the search. And we say Terraform AWS now EC2. And we hit enter. So you could see that down here on EC2, you could see AWS instance. So click on this because what we are looking for is the resource. So click on this on maybe. Now we are on the resource AWS, that's for EC2 instance. Just drag this a little. You go back to your example usage and we click on the example usage and take what exactly we want from that documentation. So now we intend to create an EC2 instance. For that EC2 instance, we need to specify what the AMI for our EC2 instance is. We need to specify what the instance type for our EC2 instance is, and possibly give our EC2 instance a name. So for that purpose, let us copy this from the documentation. And I'll drop it in the chat as well. So if you can't get that, you can easily get it here. So you have it on the chat as well. So let's go back to our VS Code and paste that on our VS Code. So there is a concept I need to explain down here. You could see that here you have your resource. It has AWS instance, and that is the resource name for your EC2 instances on Terraform. But you could see down here that there is a name here called web, and there is a concept called a logical name. This happens to be a logical name. When we deploy these resources, this resource, this name would not be what would be attached to that resource. It is a logical name that we can actually use in referring to this resource within the configuration here on Terraform. But rather what you have here as a tag will be a name that will be displayed on the resource, even at the environment of the provider. So quickly, what we will do is, let us make our first EC2 instance be, let's say, web server -1. That's the logical name for our EC2 instance. Now let us come to the point where we have the name for the tags and edit that. So let's say we have that as being web server -1 Solaris. So down here, like I talked about, that for every of the opening curly bracket, we would definitely have a closing. So if you put your cursor down on this yellow one down here, you could see that you have the closing one activated down. For this one that's open here, this purple one, by the time I put my cursor here, you would see that we'll have the closing one being activated. So what else we intend to now do here is we intend to have our AMI. So because we are on the US East one, I'll quickly go to the console and have the AMI for the kind of instance that we intend to launch. I'll drop the AMI on the chat as well, so it can be used as well. So quickly, this is the AMI. For the purpose of carrying everyone along, we are going to begin to make things very simple. As we get on in the workshop or in future workshops, we begin to now enhance that. And thanks to Solaris Tech for giving us the opportunity to be able to build and sharpen our skills. So quickly, I'll take this AMI and drop it on the chat. So on that AMI session, kindly put that, but watch just what, it's a string. So I need to have it in quotes. So now, please confirm if you are on the same page with me. Kindly drop a yes on the chat.
Sorry, are we using your own AMI or we are creating ours?
So you would use this same AMI if you are
Okay.
on the US East one, because that
Okay.
AMI on the US East one would be same.
Okay.
Or you can go and get your AMI, but ensure that you're on US East one. And you saw how I got that. I went like I was about to create an EC2 instance, and on that point, I got the AMI. So for the purpose of today, we shall be changing this to T2 micro, because that's actually the free option. So we are not charged for what we do. So that being said, that's the configuration for our EC2 instance. The first EC2 instance we are going to have on the EC2 instance file being created, which happens to be our web server. So we've had the provider and we've had the EC2 instance. I want us to give a try on what we've built so far and see eventually what happens before we begin to take it further to the next step and try as much as possible to enhance what we are doing. So I would want us to quickly open a terminal. So on these 3 dotted lines here, just click on this and you will see terminal. So click on the terminal, you see new terminal. So click on that. So you could see the path because we have the Terraform 3-tier architecture on our desktop. You could see the path and we are inside the Terraform 3-tier architecture. So what we would do, I want us switching from this point. You could see at this point here where you have the PowerShell, the drop down. Let's switch and take that to Git batch. So let's confirm we've all done that, and you could see something similar to what I have on my screen. All right, thank you. So now we are going to run the first command, which happens to be the Terraform init. So like I did explain earlier, we talked about the use for getting to run the Terraform init command. So once you've typed the Terraform init command, kindly hit enter. So you could see it says initializing the backend, initializing provider plugin, finding latest version of Archicop AWS, installing Archicop AWS version 5.310. So I hope we're on the same page. Let's study what happens on our end after we've done the Terraform init. So you could see on my end, it says Terraform has been successfully initialized. So did we have everybody get same message, please? So we know we're on the same page. If you know you got a successful message for the Terraform init, please drop a yes. Okay, so we have a lot of persons with the successful message. However, we have some having some errors. So I'll do something quickly. Anyone who had an error message, can I just have my screen shared? Just go back, quickly look at what we've done and be sure that you followed all the procedure. So I'll go back to provider.tf so you see what provider.cf says and be sure it aligns with what you have on your own. Okay, let me just take a quick look on what we have here. Okay, so Kelvin, are you sure you have Terraform installed? I doubt if you have Terraform installed. Yes, I don't think it has Terraform installed. So that ought to be something you're supposed to have done for us to be able to have a smooth ride. Okay. Which folder should I install it in? So it depends on the operating system that you are using at the moment. Maybe after this session, we could get to share and give you a guide on how to have Terraform installed, and possibly you could go through the video and have a go on whatever we are doing at the moment. So that being said, for us who had our Terraform init successful, so let's go on the next step now to do a Terraform validate. So the essence is to see that if our configuration that we've actually created is valid. So you could type that Terraform validate and click and hit enter. So as you could see here on my screen, it says the Terraform configuration is valid, and I believe we had same as well. So if we had same, let's drop that on the chat so we can move ahead. All right. All right. Okay, so that being said, let's go on the next command, which is Terraform plan. So like we said earlier, the essence of this command is to show us the changes and what we intend to execute. So now if you type Terraform plan, just hit enter. So for this file, just click on got it. And I want to show something at this point. So you see, after the Terraform plan command, you could see at the bottom, it says plan, 1 to add, 0 to change, 0 to destroy. So what this means is we are getting to add one resource from the scratch. If it were we had this resource created before and what we intend to do was a change on the plan, we would have seen that on the change. So now I'll drag this up a bit so we see what exactly it's on the plan for us to have created. So on this, you could see that we have the plus sign. So from this point, it says Terraform will perform the following actions. AWS instance web server 1 will be created. Resource, AWS instance, because that's the resource name, and this is the logical name, which is web server 1. And now you could see a plus sign on AMI. Here on the AMI, you could see the AMI that we dropped there because it's actually what we gave on the template. Now we have other parameters that will be added, but that will be known not until the resource has been created. So that being said, now let's go on applying Terraform apply. And hit enter. So now it is giving us what it wants to apply. It said, do you want to perform this action? Terraform will perform the action described above. only yes will be accepted to approve. So kindly click on yes. The reason is for you to be extra sure of what you intend to execute. So when you click on yes, it will go ahead and apply the configurations that we have set. So just do same. So if you're on the same page and yours is actually on the process of executing that command. Oh, planning failed on mine. Okay, we'll come back to yours, Raquel, and see why the planning failed. But confirm your init command actually went through. Okay, so you could see, okay, we'll come back to you, Dearbank. So you could see that it says apply complete, 1 resource added, 0 change, 0 destroyed. So before we come back to Dearbank and see why your plan actually did fail, we could go now to the console and see what we have on the console. So this is mine, and I'll go to the EC2 instances so that I see. Kindly click on EC2. Or if you don't have that on your quick buttons, you can actually search for EC2 instance. Down here on the search button, you just click on EC2. And it's going to bring that up for you down here. Kindly just click on that. So now I have instances running. I will just click on this. And down there, I have one EC2 instance running. And you could see, and it is named Web Server 1 Solaris. So this is our EC2 instance, which we've been able to deploy from Terraform and not having to have any activity to do on the console. So quickly, that's been done. Let's just see what's happening with Dearbank. Dearbank, please, can you let me stop sharing and you share your screen so that I'll do a quick troubleshoot on yours and we continue, please. So Dearbank, kindly share your screen. Okay, so with what I see there, it has to do invalid. Okay, it has to do with the rights that you have, the privilege that you have around that account. So just kindly scroll up a bit. Let's see the security token included. So it has to do with your credentials. I think there are issues with your credentials for that account. It's having difficulty get to validate that. So can you do a Terraform init again? Let's just see what happens from that point. Kindly just type Terraform init. Then hit enter. So what does that say? Was that successful? Okay, fine. So now do a Terraform plan. Okay, so it has to do with the configuration of your credentials. So Eric just dropped a message here on the chat. So kindly follow through. I believe you have your access keys and you could actually get to try that to catch up on speed. So you could stop sharing. So I continue sharing and we get back to business. Okay. Okay, so we are back on the screen, and that's my VS Code. So while we do this, let us destroy the resource we've actually created and continue to enhance our code. So kindly type Terraform. Terraform destroy. And hit enter. So on the enter value, you could need to say yes by giving a confirmation. So let me quickly show us something, why that has been done, why our resource has been destroyed. You could now see on the left part that when we created our files, we've actually created two files. We created the ec2.tf file, and we created the provider.tf file. But we could see that we have a Terraform state file down here. This state file is always updated at every point when we execute a command, because the state file needs to be updated of whatever changes that might have taken place. But however, do not forget that this state file is saved on our local, which is on our system. And that's where that concept of remote backend eventually comes up if you are working in a team where you have different developers who might want to make whatever they do get to apply to your state file that's remote at that point in time. So we are having our resource being destroyed. If we get a message eventually, we could go quickly back to the console and see what happens. Then we'll be a bit faster to try as much as possible to enhance our ec2.tf file, like making our instances be 4 instances, which is 2 instances for our web servers and 2 instances for our application servers. And reason being that for high availability, we want to have 2 of our web servers, one in one availability zone and one in another availability zone, while we have same applied to our app servers. So up to this point, are there any questions up to this point while we are waiting for the resource to be destroyed? Are there any questions we could quickly attend to? So you could see that on the resource, you could see destroy complete, resources 1 destroyed. So that EC2 instance, which is the web server we deployed now, has been destroyed just by that Terraform command. And I'll take us quickly to the console to see the status of that resource. So this happens to be that same EC2 instance. If I do a reload here, you would see that we no longer have that EC2 instance as part of my running instances, because we already carried out a destroyed action. But now you could see that on the instance state, it is stated there as being terminated. So I'll go back to our VS Code and let's continue. So now back to drag this down, and let's go back to our ec2.tf. So, like I did explain, we need an additional web server and we need 2 more application servers. So we can just copy this code block. Come down and paste it. All we need to do is edit some. So now this is what we are going to use and have as our web server tool. So what we can do on this is just to edit one down here and make that 2, and come down on the name and make that 2. So this is web server 1, web server 2. I won't have us get to do the init and try to execute this, that because we understand already what that is going to do. But let's go ahead and make 2 more EC2 instances that we'll rely on eventually. So kindly do same with me. So at this point, for the very first one, all we need to do is to edit this and have this be our app server. And we could name this app server 1. And we take this block again, down here to on the name, ensure you edit the name to be app server 1. So for the second one, kindly edit to be app server 2. So that is our 4 EC2 instances all being worked upon in the same US East 1, which is North Virginia. So we have 4 EC2 instances down here now. So if you know you're on the same page with me, kindly drop a yes. So we'll take a quick execution action and see what happens before we leave the EC2.tf file and work on other files that we need to ensure our 3-tier architecture. So if I need more yeses on the chat, so I'm sure everyone is being carried. All right. Thank you very much. So let's move ahead. So now, because we already initialized this directory, we might not need to do a Terraform init. So what we can just quickly do is do a Terraform plan. Do a Terraform plan and hit enter, and let's see the plan of what we intend to execute. So I would drag this up so everyone sees what we have here. So on why is this doing this? Okay, I believe on our own end, we could actually see the summary of what we intend to have executed. So that being said, let's do a Terraform apply and see what happens. Oh, that's wrong. Okay, so on our Terraform apply, you could see it says 4 to add. 4 to add. And you could understand that, we destroyed the first one. So because we destroyed the first one, now it is getting to deploy the 4 resources all over again. And here it has given us a summary of all what we intend to add at this point. You could see web server 2 happens to be the last. Let me just draw this up so we see what that actually is. We have web server 1. We have the app server 2 and app server 1. So let's come down and just type yes and click enter. So you could see now that our EC2 instances are being created. So it says web server 1 creating, web server 2 creating, app server 1 creating, and app server 2 creating. So while this is also being done, our state file also would be updated. And that was why we had that pop. So if we've done same and everything is going on smoothly, kindly drop a yes on the chat before we go on the console to ascertain what we've done. All right, perfect. So you could see this eventually would update our state file. So you could see that we have apply complete resources 4 added. So I'll go quickly to the console and let's see what we have on the console. So down here, I will refresh this. Now on the console, you could see what we have here is web server 1, web server 2, app server 1, and app server 2. These are the instances and we have them running, all T2 micro. So that being said, we'll go back to our VS Code and quickly destroy this while we enhance our code. So quickly type Terraform destroy and hit enter. Then type yes and enter again. So while that is ongoing, we need to understand something that we intend to create a 3-tier architecture that is highly scalable, highly available, and secured. So now, these resources that we've actually just deployed now were created in a default VPC. So it will make sense for us to have our own virtual network where we would have our resources deployed into. So at this point, the next file I want us to go ahead and create and work on would be the VPC file. And that happens to be the vpc.tf. So while this is being destroyed, once that is complete, we'll go ahead to create a vpc.tf file. Okay. So let's come back to the Terraform again. And we click on new file. When we click on new file, we create a new file, vpc.tf. So what we have here is we have 3 files down here. We have provider.tf, we have ec2.tf, but now we are in our vpc.tf file. And to be able to have the template, we need to now go back to search for VPC as a resource on the Terraform documentation. And that takes us back to our search engine. So I'll close this, which happens to be the one we use for the EC2. We might be needing it later, but we'll search for it and come back to it. So here, you just type Terraform AWS and we put in VPC. And hit enter. So when you look for these resources, ensure to look out for the one written resource. So if you look before this down here, we had some at the top. We had modules, we had some others. But what we need is resource, and that needs to come from the Terraform, itself. So let's open this and see the example usage for VPC. So now this is the documentation for VPC on Terraform for AWS. And let's just click on the example usage down here. So now, when we click on the example usage, we could actually see this first one, and it's basic. This is just to say AWS VPC, and this happens to be the resource name, and it says main. So in this context, main is a logical name, which we could actually change to fit into whatever we want. And here is a CID arrow block given. But rather, I want our VPC named. So like we said, if we put a name on the logical name, that name would not display on the VPC on the console eventually when that's been deployed. So what we need to do is to make sure that we take an example usage that has a tag. So for that purpose, we need to take this one, this second one here. So kindly copy this code. And I'll take this first to our VS Code because I need to remove something, and I will explain why. So now this is our template. We bring it down here and we have it pasted. So now we intend to rename the logical name for our VPC. So for that, I could just come here and name this VPC-Solavis. So now for this CID arrow block is something we can actually alter depending on how we want our VPC structured on the range of IP addresses we want within that VPC. So for this purpose, I will work with 10.0.0.0/16. So this line that has to do with dedicated instance tenancy, and it says dedicated. I'll take this off because at the moment we don't need that, because we don't need this for the purpose of today. Now our tag, we need to give this a name, and let's quickly just change that to Solavis VPC -1. So this is the VPC we intend to use for our activity today. But not forgetting, like I said earlier, it is good when you get to build your codes and you get to test them in bits. As much as I know that we would need subnets within this VPC, I would want to quickly go ahead and try the inclusion of this VPC on the template and to see if we have it being good. So quickly, let's just do a Terraform plan. We hit enter. So we've seen what it intends to do. So we had 4 resources before, and now it's adding 1. So when you click on Terraform apply, that was wrong. Terraform apply and hit enter. And just accept, yes. So that is actually now being created for us. So while that's being done, let me just create a background on how we intend to go about our subnet. So now we're about having a VPC for the purpose of today. So, but we'll go further and have 4 subnets created, 2 subnets that we're going to make public, and 2 subnets that we intend to make private. All are going to be within our VPC. So we'll do a quick check on what happens on the console after this command, and we come back and enhance our code. So we could see that the Terraform apply has gotten that execution done. I've gotten that execution done, and I'll just quickly do a check on that. So now I'm taking us back to the console, and this time around, we could just type VPC. I have it on my shortcuts already, but if you don't have it, just type VPC on the search, and you would see this, and kindly click on it. So when that comes up, you see the list of VPCs here. Just click on this. And here I have a list of the VPCs on my account, and this happens to be the Solavis VPC, which we just created. So we have that as being all good. Confirm you have yours created as well. Just drop a yes on the chat before we go back to the VS Code and enhance our VPC.tf file. Yeah, more yeses, please, so that I'm sure we are all carried. All right, that's fine. Okay, so let's go back and destroy that, and we enhance our code. So Terraform, destroy. And that would destroy all the resources we have created a while ago. So here, kindly click on yes, or type yes and hit enter. So it's being destroyed at the moment. So while that is being destroyed, let us quickly go to get the documentation for the subnet. And that takes us back to, I'll close this. That takes us back to Terraform AWS, and we type subnet and click enter. So the very first one here says AWS subnet, and it's resources, so we can actually get this. So we quickly get this and click on the example usage down here. So now, this is pretty straightforward. This is exactly what we need, and we'll just copy this quickly and take that back to our VS Code. So earlier, like I said, now because we want to make things very simple, at this point, we would create another file for subnets. And for that to be done, let's just click on Terraform here and click on new file. And we could say subnet.tf. And that's a new file created for us. Now, what we copied, we can just come here and simply paste it. So now, here on resource, we have AWS subnet. That is the resource name. But on the logical name, main doesn't happen to be what we want. So we need to change that to be something we can actually refer to whenever we need that. So we could say our first one would be our public subnet. Public subnet 1. That's our first VPC, our first subnet. And I'll come to the tag and change the name now to Solavis -public subnet 1. So now on the CID arrow block, I believe we all understand how this comes about. So /24, this is actually to give us the number of IP addresses that can be used within that VPC, subnet within the VPC. So I think we are fine with this, and we'll go ahead with this. Let's go ahead and build the next block, and that's, let's work on the VPC, sorry. So now it says AWS VPC.main. if we go ahead and use this, we are not making this subnet be inside our earlier created VPC, and that's not what we want. We want this to be the public subnet 1 within the VPC which we created earlier. So what we can do is edit this. So we already know AWS VPC, that is the resource name for all the VPCs. But now we need to have that logical name for our own VPC which we can call upon. So for me, I have the extension. I can quickly just take this off and say AWS, and it's going to bring most of the resources, and I say underscore V. So it has brought the VPC which we used, which we created earlier, and that's that. So what we are trying to now say at this point is, I want you to create a subnet for me, which is going to be named SolarVis Public Subnet 1. Well, I want that SolarVis Public Subnet 1 to be inside the VPC called AWS VPC SolarVis. That's this. So let's quickly do this before we come back and enhance the other VPCs. But let's be sure that this would actually be in that VPC which we had created earlier. Okay, I'll take it. I'll be slower now. So thank you for that feedback. Thank you for that feedback. So let's just so let me take us back so that if anyone didn't actually catch at any point in time, we could just get to recap that. So what we did was we had a VPC created earlier, and that's this. So if you want to see what we have on the VPC block, this is what we have on the VPC block. There we named our VPC to have a logical name, SolarVis, VPC SolarVis. But the name for that resource was SolarVis VPC 1, which will be different from what you have as a logical name. It is with this logical name that we can refer or call this VPC whenever we need them within the configuration template. So moving away from the VPC, what we did was yeah, thank you, Blessing. That's true. It was definitely going to bring us back. Thank you. So what we did was we came now to the documentation to get the documentation for the subnet, and that's Terraform AWS subnet. So I'm looking out for this, and which was this file. We took the example usage, and which was this we copied. I think it's on the chat already. You can actually get it there. And we came and created a subnet .tf file where we had brought now all of that resource. So this is the subnet.tf file. So here, we've only just mentioned AWS VPC, that's the resource name, VPC SolarVis, but what's needed here is actually the attribute, which is the ID. So this is actually what we need. So it is with that ID at every point in time, this subnet will realize that I now know the identity of the VPC which I will be created in. So that being said, let us quickly do a Terraform plan and see what happens. Yes, we need to have the VPC before creating the subnet. And that was why we worked on the VPC file first, before now working on the subnet file. So now it is saying 6 to add, and let us apply this and see what happens. So it's being created at the moment. While it's being created, if there are any questions, any concerns, you could just raise them while we get to attend to that, and we fall back to developing our codes. So if there are no questions, Doc, would you want to, while waiting, give an insight as to what happens at SolarVis if we could actually have people come learn Terraform at SolarVis? Just give a quick insight onto what happens at SolarVis around Terraform, and we head back to what we are doing.
Thank you very much, Bisan. Thank you for the great job you're doing. We truly appreciate you. So, guys, you can kindly follow us on the following pages. All right. So, at this moment, you can equally just drop your LinkedIn URL so others can connect with you. Like I said, through these sessions, you'll be able to probably have potential employers. You'll be able to have people who would probably refer you to great opportunities. So do not hesitate to make useful connections right here. Reach out, guys. For those who would have other persons who are looking forward to getting amazing training, you can reach out to us. You can equally reach out to me specifically. We could have conversations on the side of full boot camps, especially those who do not have any IT background. Have no worries. Myself, I never had an IT background, but I was able to transition, and I know what it takes to be able to do that, especially from Africa, where we have lots of challenges with internet connectivity and all of that. So you can equally reach out to me via this contact. Let me just send out the chat. And also, our program right now is fully on AWS and DevOps, but we are looking forward to launching a cybersecurity program sometime in February, and we're equally going to be having a flyer for our next batch, which is going to start on the 6th of March. So shortly, we're going to have that flyer made available. Probably, I think Eric can drop that in the chat. And our bootcamp actually, like I said, focuses on AWS as well as DevOps. We cover mostly cloud agnostic, we build pipelines. So in our software workshops, for those who are not aware, we're equally going to share with you the entire calendar schedule, right? For the entire calendar schedule for our subsequent workshops. And so you want to mark your calendar not to miss. We have a lot in store for everyone. So on what it takes, please kindly reach out to us so that you'll be able to get more insights. And we always like to make it customized. You could have specific questions. We'll be able to address your questions. And what we're trying to do is we're trying to tailor our solution to the client's need. So this is a flyer, as you have in the chat, of our workshop schedules. All right, the next workshop is coming up on the 20th of January. So you don't want to miss that. And thereafter, we're going to be building pipelines and so on. So for now, I think that's it. Since we've been able to apply our changes, I'll pass it over back to you, Misan, so you can continue. Thank you very much, and over to you.
Thank you very much, Doc, and thanks everyone. So let's just quickly go to the console and see if we have our subnets in the VPC as stated. So I would want to reload this. And we have, that's our VPC. I'll quickly go to subnets and let's see what we have there. So these are subnets I have. I believe this is the subnet we just did create, but I want to do a filter. So just come here and you would see filter by VPC. So now the very first one here happens to be SolarVis VPC1. You can click on this and you would see that while you apply that filter, we have only one VPC, one subnet being displayed. So what this means is this subnet is within that VPC. So which means our configuration template is okay and we can go back and have it enhanced. So let us do a quick Terraform destroy. So while that destroy action, just click on type yes. So while that destroy action is being executed, we would now get to enhance this template to have our second public subnet and 2 other subnets, which we intend to use as our private subnets. So, but once we have that done, we need to give an internet gateway and a NAT gateway to our VPC for reasons to have access to the internet. So let's just copy this block. And we paste it. So this would be our public subnet 2. And let's just edit the logical name and also the name on the name tag, as well as change this from 1 for the CIDR block. We'll change this from 1 and make that 2. Reason being that we don't want the CIDR block for the subnets within the VPC to okay, so are we all done that now? If we've done that, kindly drop a yes on the chat, please. Yes, we don't want the interference of our CIDR block, and that was why we changed that. All right. So what we can do at this point is let me just see what we have on the chat. Sorry for that. All right. So what we can do at this point is to copy again. We've actually edited for the second public subnet. And let's copy this block and get to edit for our private subnet. So let's make this private subnet 1. And let's make this private as well, subnet 1. We can copy that block again and do for our second private subnet. So we could just change this to private subnet 2. So yeah, we've had a configuration template done for all 4 subnets. So if you are at this point, kindly drop a yes. So before we go ahead and see what we have. All right, drop a yes, please. Drop a yes so we know everyone is being carried. Drop a yes. All right. All right, we are doing good. We are doing good. Okay, so that being said, let's quickly do a Terraform apply and see what we have with that. and we click on yes. So we have our resources being created. All right, so while that's happening, we'll go now to the console to check what's been done for us. However, we need to come back and have an internet gateway being set up. But we would come back to this configuration to be able to place these subnets in different availability zone within our VPC. So what we've done here now, we just have the subnets being decided at free will, but eventually we need to dictate the availability zones which we want this subnet to be. Okay, so let's just have that done rightly, but let's check what happens on the console. So quickly go to the console, and at that same point, just do a refresh or a reload. Okay, Achim, we'll come back to you, please. What did we do here? Okay, so it's been added. So let's apply a filter and see. Okay, let's see what's happening. Okay, let's hear from you, Ashim, while I get to see why we are having this. Ashim, you can go ahead.
Can you hear me, sir?
Yeah, we can hear you.
Thank you so much for that's a nice session here. So I have a question. So after we applied the Terraform, right? So I've seen that the Terraform creating the resources like a server. Can you go back to the EC2 to see if we have created those server?
Okay, so when we did that, we're always going to check. So, and that's why we are here on the console. I understand your question, to see if whatever we wanted done with our code eventually was executed.
Right. My
is that what you
question
mean?
is, yeah, my question is, I was just wanted to refer the IP, right? So we have the private and public subnet, right? And with a specific range. I was wondering that, is there any correlation between the EC2 IP and the subnet? If so, and then how the VPC can create us that IP address for our server? How, based on what it's gonna pick up for us a specific IP?
Okay, I think I get what you mean now. So because we are still getting to enhance our code, it will get to the point where when we've placed our subnets in the dedicated VPCs, it will get to the point where we go back to the EC2 .tf file and also state the subnets in which we want those instances created. So like I explained earlier, we want to have our subnets want to have our EC2 instances, which is the web server and the app servers, in 2 different availability zones. And each of those availability zones would be the different subnets. So eventually, when we are creating our EC2 instance, there will be an argument where we would give the subnet ID, which we want those EC2 instances created. And when we do that, we have also given a constraint on the IP addresses that will be assigned to those EC2 instances, because at that point, whatever IP addresses that is being assigned to those EC2 instances will have to be an IP address that falls within the CIDR range. So I don't know if that gives you clarity.
Is there any correlation between the EC2 private IP and the subnet IP or private IP that we have it?
So when you say the EC2 private IP, whatever private IP that the EC2 instances would have has to be what falls within that subnet, because what you have on that subnet that must have been dedicated for that is a range, and that's what is definitely going to allow internal communication between your EC2 instances. So when you have now, for example, your VPC and it says 10.0.0.0/16, that is a range of IP addresses. Now we are subdividing that VPC into 4 subnets. So when we now create EC2 instances in the different subnets within that VPC in different availability zones, there is still going to be that local internal communication between these EC2 instances, and that local internal communication exists only basically with your private IPs, because that communication is local and within the network. So I think, I don't know if that's clear enough for what you intend to understand.
Yeah, that's pretty good. But I was thinking that how the VPC when we apply the Terraform, right? So we create the resource set. I was wondering that how the VPC able to create and pick up the IP for our instances. And is there any correlation between the private subnet IP and the private IP for EC2 instance? And I was wondering that if there might be some correlation between the Elastic IP, because we have already assigned that, and then the Elastic IP is going to pick up those things
Okay, so let me explain something, Hashim. So the concept is quite straightforward. This is actually not an Elastic IP yet. So what I was trying to explain is, don't forget that VPC is a range. So whatever happens within that VPC is whatever we define. And now we have come up to create 4 subnets within that VPC. So as much as we've created 4 subnets within that VPC, on the EC2 instances, we are still in the position to take the subnet ID, which we want those VPC created. So by doing that, we are keeping some constraints. So for example, if I say web server 2, I want web server 2 in public subnet 2. So what that means is the IP range that falls within that subnet for public subnet 2, that EC2 public IP is definitely going to fall within that range and not go away from that range, because it's something we have defined. So that's the reason for us. Yeah, so that's the reason for us defining the CIDR block at the point where we are creating our subnets.
Yeah, so, that makes sense.
All right. Thank you very much.
Right,
so
thank you.
Welcome. So back to what we had ongoing, we did create the subnet and wanted to check and be sure that the subnets were in that VPC. So we could see that we are on subnets here. And before I applied the filter, these are all the subnets I have on this account. But by the time I apply the filter to get all the subnets in SolarWinds VPC1, which is this, we now have just those subnets that were specified to be created in this VPC. So we are good at this point. So if we know we all had our subnets created in the VPC, kindly drop a yes before we go further to enhance our subnet and have it be in different availability zones. Yes, let's have a yes. Let's have a yes. Let's be sure we have everyone carried. Okay, so we have a Taiwo, could you do a reload? Okay. So let me stop sharing, Taiwo. Let's see what you have on yours, if we could render help before we go ahead. So I'll stop sharing at this moment. Kindly share your screen. Okay. Nobody subnet. Okay, so if you see from the error, it says creating subnet, invalid subnet. The CIDR 10.0.2.0.24 conflicts with another. So just go up. Let's see the very first one. Well, you just take it up. Let's see the very first one. 10.0.3.1. Go down, please. Then go to the last. Let's see the last. 10.0.0.4. Just hold on. With subnet public subnet 2, line 10. Resource public subnet 2. Okay, so go to line 10. Public subnet 2. AWS subnet. Could you take it up a little? Let me see. We don't have any of your logical names conflicting. Public subnet _1. Public subnets _2. Okay, please take it down. Okay, hold on. ID. 1. Okay, so take to the last one. Okay, just hold on. Okay, Stephen, could you share your thoughts? I think you say you were saying something. Hello, Stephen. Could you share your thoughts? Okay, so run it again. Let's see. Just run a plan and
Okay.
do a Terraform plan. Yeah, go ahead, Stephen.
Okay, what I was saying that he should check his AWS to see whether there's any conflicting subnet already created with respect to that.
That's true.
Or he can still like.
We could alter this and just see what happens on that second one. But just do a Terraform plan again and let's see. So do a Terraform apply. Yeah, kindly type yes. Okay, so that's been done. So obviously, maybe before the very first time, you had your CIDR range for your subnet conflicting, and maybe somehow you had that fixed. So now, if you go back to the console, you will have to see those results. So you could stop sharing, so I continue sharing and we move ahead. All right, thank you.
Thank you.
Okay, so that's it. Let's go back to our VS Code and get to destroy that. So while that is being destroyed, we could type a yes for that to happen. So while that's being done, let's go back to the documentation for the subnets and see how we could have the availability zones imputed. So this is the argument reference for availability zone. We can just click on it. And it says, availability zone, that's what we have here. It's a optional, AZ for subnet. So we can have it, take it down to our code and get to state what we want on each of them. So now I've copied that. I'll take it back to the VS Code for each of the subnets, and we'll try to state where we want it placed. So for public subnet 1, I'll do paste this, give a space equal to, and now that has to be a string. So we could say US-east-1. So let's say 1A. Confirm we're all together, please, with a yes on the chat. Okay. All right. So I believe we understand the concept here as to how we want the availability, our subnets in the different availability zone. So this is our public subnet 1, and we want it in US East 1A. So we also want a corresponding private subnet to be in the same availability zone with this subnet. So let's copy this and take that to, let's copy this line and take that to the point where we want it to be in our private subnet as well. So this would be for our private subnet 1. So we've had our web server and our public subnet and our private subnet 1, each of them in one availability zone, which is 1A. So our second public subnet and our second private subnet, we'll want them in another availability zone. So let's copy this and now take this to our second public subnet. So we could now edit this. Instead of US East 1A, we could edit to US East 1B and copy this and have it on our second private subnet. So that's the idea. So we've had this done. Can we just drop a yes on the chat so we're sure we all have this done? I could copy the entire code and as well drop on the chat if we want. So who else has this done? Just drop a yes so we are sure we're on the same page. All right, all right. So that's fine. We could also still go ahead and get to try this, but I think it's pretty clear we can leave this because we already know how to have that done. So the next thing we want to quickly do before we come back to do subnet associations and things like that, let us now have an internet gateway for our VPC. So ordinarily, if we were having to have a module, we could want to have things having to do with the VPC in one module, but not yet. We would have all that done in subsequent session. So for now, let's now create another file. Let us go to our Terraform and create another file. Kindly click on New File. And let us call that igw.tf. So I believe we've all created the internet gateway file. If we've done that, drop a yes on the chat so we're all on the same page. We are making progress, good progress. All right. So now, just like we've always practiced, we need to now go back to the documentation, Terraform documentation, and get the guide for the internet gateway. So this is Terraform AWS subnet. I'll edit this and simply put internet gateway. So now we could see AWS internet gateway resources, and this is what we want. So all we just need to do is get to have this opened. And example usage, we have that down here. So let's copy this. I'll drop this on the chat. And I'll take that to my VS Code quickly and have it pasted. So now we've gotten the template for the internet gateway to be created. So now the resource name says AWS Internet Gateway, and the logical name is GW. We could actually change this and quickly just put something like IGW Solavis. So on the name, we could also still change the name tag and have it to be Solavis-IGW. So now what we have on the VPC that needs to have this internet gateway, here it is written AWS VPC main, but that's not what we want. We want our own VPC. We want this internet gateway for our own VPC. So we can quickly just type this, AWS _VPC Solavis.id. So that's this. So let's all do this and we'll go ahead and run this and let's see our internet gateway and the different availability zones that we had put our subnets in. So if we're at this stage, let us just do a yes on the chat. So we go ahead and have this executed. Okay, that's fine. That's fine. All right. Okay, so let's quickly now do the Terraform plan. And now we can now see what we are about to have. So let's just quickly do Terraform apply. So when that's been done, it will ask us and we do a yes And while it's being created, we can now go back to the console and check that VPC. So basically, when we check that VPC, we want to see the resource map for that VPC and see what we have in that VPC. After that's been done, we need to now create a NAT gateway for the VPC as well, so that when we have our resource in the private subnet, they can actually use that NAT gateway to get updates for patches and the likes. Okay, so that's been done, and I'll quickly go to the console. And firstly, quickly, I'll go to the VPC and so let's select the SolarVis VPC one. We can scroll down. And while we scroll down, let us just click on the resource map. So you will notice when we click on the resource map, that you have down here SolarVis Internet Gateway. That is to show that the Internet Gateway, which we just created, has been created for us and attached to this VPC. Also, in a similar manner, we said we wanted the public subnet 1 and the private subnet 1 to work in tandem and be in US East 1A. And also, we made the public subnet 2 and private subnet 2 work in tandem and be in the US East 1B. So that shows that we are still on track. So at this point, we would need to now get to destroy this and get to enhance our code. So let's do a Terraform destroy. Okay, so let's do a yes quickly. Okay, so Stephen, we could actually see your question. So you could actually get to have everything built in one file, but it's going to be a lot more confusing. And that's a good thing about Terraform, because Terraform tends to have features that makes you better organize your code and your environment. And that's to say that eventually when we begin to get a bit more advanced on the workshops that we are having, we'll begin to explore some of those features and see how we could better manage our code and see features that makes Terraform somewhat a better option than maybe CloudFormation, depending on the aspect that you are looking at that from. Okay, so we've had our resources destroyed. So let's quickly now create a file. At this point, let us create a file. And that's going to be our NAT gateway file. Just click on create a file, new file, and let's say nat.tf. So here we have the NAT gateway file now. So we now need to go to the documentation. And yeah, you're welcome, Stephen. We'll now need to go to the documentation and get that. So I'll close this quickly. and do a search for NAT gateway. Okay, but now not forgetting that I said something earlier that before we go ahead with what we do on Terraform or on our codes, we need to understand how these things work on the console. So a NAT gateway actually would not work without an elastic IP. So firstly, what we need to do, we need to create an elastic IP. And once that is being done, when we're about to create a NAT gateway, the NAT gateway actually will depend on that elastic IP. So at this point, we would rather want to leave this file, go and create another file for the elastic IP. So let's create a file and call it eip.tf. So are we all there? If we are there, please let's drop a yes on the chat. So I'm not too fast, or we have everyone being carried along. Are we there? It's a bit quiet on the chat. Okay. So someone has been somewhat ahead of us. That's good. That's good. So let's quickly now go get the documentation for the elastic IP, and so we could have ours created. So I would rather look for the elastic IP here. So this happens to be that resource. So let's open that and go quickly to example usage. Okay. IP. All right, so we could have, we could get to use this. So now we could just edit this. And down here, we change this to actually be AWS instance web ID. Okay, so let's edit this to be for one of our EC2 instances. Okay, let's use the first one, .id. So I think we are fine this way. So at this point, we have this line already for our elastic IP. So let's go back now to the NAT gateway, but let's edit the logical name now for our elastic IP. We can as well put a tag so that we have it named. So for logical name, I would want to have it as EIP-Solavis. So for the tag, let's just have this, and we could come back and have it edited. Okay, so let's make our template this way. I believe we understand all we've just done here, and we'll go to the NAT.tf file and eventually depend on this. Okay. Yeah, we'll put that on the chat. Thank you. Thank you. Okay, so let's quickly go to the nat.tf file and go back to the documentation to check what we need. So this is what we need. We could simply take the example usage. So just a minute, please. Okay, we could take this. And eventually come back to add the depends on argument to that. We could remove the allocation ID. Okay, so, okay, Stephen, go ahead and ask what you want to ask.
Okay, sir. If I may ask, I don't know. I thought that, like, I don't know, when I used to like create my own NAT gateway, I thought that you could actually like associate like not code wise now. I thought you can, like, while creating a NAT gateway, you can actually associate an elastic IP to that NAT gateway rather than like normally most people would like to associate the EIP to the instance itself. I thought that you can actually like associate it with the NAT gateway, then the private instances, the instances in the private subnet will now use
Yeah.
through that NAT gateway to be able to speak to the internet.
Okay, so I understand what you're trying to say, but there are several ways you could actually go about this. And when you talk about the instances in the private subnet, so what we intend to do for high security, even our 4 instances, we intend to have the 4 of them in the private subnet. It is eventually when we have a load balancer, it is the internet-facing load balancer that we're going to place in the public subnet. I don't know if that makes sense.
Okay, so that means like if there is probably an instance like hosting maybe a website, a public facing website that you want your customers to see, like, is it that
Yeah.
all those things will be inside the private subnet and you will have to still use that same mechanism of using a load balancer to be able to like get them to speak to that instance?
So you can have them be on the private subnet while you have your load balancer in the public subnet accepting traffic and requests from the public. So when those traffic come, your load balancer now communicates with your EC2 instances using the private communication and gets response back for the end users eventually. I don't know if you get what I mean.
Okay, yeah, I understand what you're saying.
Yeah. Okay, so let's move ahead, please. So let me quickly see that argument for the depends on. Sorry. Is recommended. Okay, we can actually now use this. Okay, so we need to now change this internet gateway to be the internet gateway the one we already created. So let's change this to our subnet ID.
I thought the internet gateway was Internet Gateway Solaris.
Yes,
Online.
so yes, that was why I left that. I'll get that with the extension now. Just hold on. Let's edit the subnet first. Subnet. And we could use this .id. So we could change this to be Solaris, not Benson, AWS. Let's quickly see that. IGW Solaris. Gateway. So why am I not getting this? Just hold on. I don't think we're getting that right. Don't know what the problem is. Okay, just hold on. Let me do a quick check on this. Does not. Okay. .id. So we're supposed to have the allocation ID. EIP-Solaris. I don't know why that's not coming up. Oh. Doc, do we have Eddie there on the call?
No, we don't have Eddie right now on the call.
I'd wanted him to
take a look at it. Take a look at your chat.
okay. Let me see.
So are you talking about the name of your internet gateway?
Yeah, so I'm trying to actually have it being called upon. Wait, let me just see on
So
this.
did you put R as part of your Solavis? Did you put R?
No.
Okay, you
Are you
don't have,
seeing
okay.
arrows somewhere?
So I'm asking for your SOLA, do you usually put R? Because I usually put R. Your Solavis.
Okay, no, I don't. No, I don't.
Okay,
So
because
hold
now
on,
it
let me
came
just
up.
get this off and see if this works now. And see what will actually be the problem. Resource of this, not gateway, not Solavis. Then solve the ID. Solavis, not. So we would need the allocation ID. Just hold on, so I check. Okay. Yeah, Emeka, I get what you mean. So we'll have a result. I think this should be it. Let's see. Okay, AWS Internet Gateway, IGW. Yes, I think this is the correct one. So not gateway, not Solavis. Subnet ID. Yes, so the Internet Gateway. Okay, I think this is fine. Let me just see what I have on the Internet Gateway. No, this is for my NAT. Sorry. This is for my NAT. That's what we should have here. This is what we should have here. So on Internet Gateway, this is fine. The EIP one is what I need to now work on. Yeah, Mika, I think that's correct. Okay, so this should be, this on NAT is fine. But the NAT won't run now because it needs to depend on, okay, yeah, so the internet gateway is actually here. Yeah. Okay, just, oh, don't do this. Let me just do a quick command and see what message I will get, and that will help me. Just hold on, please. That is 10. There's still a trouble with that line. Yeah, I think so. Okay, let's take that off and see what happens. Okay, that's fine. That's fine. I think we got what the issue is now.
I have a question, please.
Yeah, go ahead. Thanks, Emeka, for that.
So
Go ahead,
on
please.
Terraform, we have the allocation ID, but here we don't have it. So what is the use of the allocation ID? Because we don't have it on our code in Terraform.
So that allocation ID ought to have been when we have the Elastic IP created, and now we come back to our NAT and actually refer to that. So okay, so what is this saying? So that's what we are having here at the moment, and that was what I wanted to refer you to, that it was definitely going to refer us back to that allocation ID, because we need that Elastic IP to get to have our NAT done. So this NAT.tf file is okay, but all what we just need to do now is to have the EIP created and have that allocation ID at this point. I don't know if that makes sense. So we'll come to the Elastic IP EIP.tf file, have this template done, then get to refer to that on the NAT at this point. So that's pretty straightforward now. So let's go and make the EIP file and get to now call on it on the NAT.tf file. So this is what we need. EIP associated with an instance. Let me just see what other options we have down here. Multiple EIP, no. Okay, so let's take the first one. Yeah, Stephen, go ahead.
Yeah, sorry. I don't know. This the multiple EIP, it was also relating to the question I was asking before. So it's
So
of
could you
no
come
use.
again? Come again with the question
No,
so
like,
I understand what you mean.
okay, the question I was asking is does it have to always be that maybe when you want to be able to speak to the internet through your internet gateway, must you always associate the Elastic IP to the instance itself, or can you associate that Elastic IP to the NAT gateway, then put it inside a public subnet, then your private subnet will now be able to speak to that to the internet through that public subnet because of that NAT gateway that is in the public subnet? That's what I was asking.
Dr. Samba, do you get that question rightly? I don't rightly get that question. So even responding to it, I don't know where to.
Okay,
Do you
yes,
get
I
that
think,
question rightly, Doc?
yes, I think I get his question, and just give me 1 second to try to see if I could be able to put a picture to his question. I think it's something like this. 1 sec. Okay. I think it's something like this. Right, let me share my screen. Just give me 1 second as I share my screen.
Yeah, let me stop sharing, then you do that.
Okay. So if I get him very well, I think his question is something like this, right? Normally we should have, let's say we have our VPC as such, and while in our VPC, okay, let me see. We have our VPC as such, while in our VPC, let's say we have public subnets, and then we have private subnets right here. And then in the public subnet, let's say we have our NAT here. And then the private subnet, let's say we have a private EC2. So this is our pub, and this is our private. And then we have our internet gateway right here. So this private EC2 wants to talk to the internet. So normally it has to pass through the NAT for updates and patches, and then the NAT is going to translate it to the outside internet, right? So he's asking the question, our EIP that we're creating, instead of creating the EIP and probably associating the EIP directly to the instance itself, let's say the instance in the private subnet, directly associating it here, can we associate the EIP directly to the NAT gateway in such a way that this private instance is going to leverage this EIP, which is associated to our NAT in the public subnet, to be able to get updates and patches on the internet? Did I get your question right, Stephen?
Yes. Like through, and through specific routes, yeah.
Okay.
All right,
which
thank you.
Okay,
go ahead.
NAT gateway.
No, go ahead.
Yes, so that means associating to the NAT gateway rather than associating directly to instances. That's his question. Over, Misan.
Okay, thank you very much, Doc. I think I rightly understand what it means, but at the end of the day, there are several ways we could actually go around that. So I was looking at the EIP documentation on trying to understand and put my knowledge of how that works on it. And I already see what I think we had as a problem, and I would do that now and explain that to even Stephen, so we see it differently. So I'll quickly share my screen now. Okay. Okay, so can you see my screen now, please? If you can see my screen, just drop a yes on the chat so we move ahead. I just tried the code differently and I want to see what happens. Then I explain what's around that. So earlier when we started, someone asked about troubleshooting and the kind of errors we could actually encounter. So I think, was it Eddie who responded and says the joy of it at times is you getting to meet errors, you try to resolve them, and eventually you get learnings from them. So this is just like one of such typical example.
Prof, can you please scroll up so we can see that code?
Okay, I just want to see what happens on it, then I'll give an explanation as to that. Okay, so it will be fine now. I can see from the message we have here that our EIP has been already created. And once the EIP has been created and we get to refer to that EIP on our location ID, we will be fine. So let me just see a positive message here. Then I'll take us back to understanding what we actually are to do. But normally with a NAT gateway, it takes some time. So we could see now that there is a positive message as to having a NAT gateway already. So let me just take us through the different files. So quickly, if we go to our NAT.tf file, which I happen to be at the moment, let me just take this down. You could see that the resource is NAT gateway, and we named the logical name for the NAT as NAT-Solavis. But like I earlier said, we cannot go ahead and create a NAT gateway without getting to create an EIP. And that EIP is this file down here. So this is the resource. It is saying AWS EIP. That is the resource name. And my EIP is the logical name which I am giving to the EIP at this moment. So that being said, this other line that talks about instance, I think this is where Stephen also has some concern. What I have now succeeded in doing at this point is I have commented this line. So having to comment this line, what that means is this is an independent EIP on its own. So what happens in this point is this EIP is not associated yet with any instance, right? Neither is it associated with any subnet. Because normally, even when you are to use a NAT gateway to use an EIP to create a NAT gateway on your console, you usually will create your EIP independently on its own. So I don't know if you get that concept. So that being done, we now have this template for our EIP. So when we come on the template for our file for the NAT, we are now on this allocation calling on that particular elastic IP to say, I had you create this elastic IP for me earlier, and I want you to use that now for my NAT gateway. But nonetheless, we are now using this subnet ID to say, this is where we want our NAT gateway eventually placed. And now for this, I will change this. We are not supposed to have it in our private subnet, but rather we are supposed to have it in our public subnet. So I will change this now to public 1. So let's go through the code, have as done, then we could now give it a try. I tried mine already and it has worked. So you could do a Terraform plan after this and do and apply, and let's see what happens at your own end. So Stephen, you got that right?
Yes, sir. Yes, sir. I just saw what I was trying to figure out, like how to create that individual EIP without adding anything to it.
Yeah.
So
So that was
you.
actually
Yeah.
where we had the trouble initially. So if we've got that done, let's get a response on the chat so we see where we are on that.
Can you please show the code for the NAT again once more?
Okay. Okay, I can share that on the chat if you want. So this is for the NAT gateway. So that's for the NAT gateway. I'll drop the code for the elastic IP as well. Okay, so there it is on the chat. Anyone with a feedback on what happened on your code, your end? We could unmute at this point and give your feedbacks, please.
I'm having an error. I cannot figure out where the error is coming from.
Yeah.
All right. So everyone, thank you very much At this point in time, I think we can, we are kind of 6 minutes to the end of this session. So those who have errors, please just kindly raise your hand. I think we have someone was on the mic. You can kindly share your screen so Mason can troubleshoot you. Let's see where you have the challenge. As we wrap up this session, like we said, we're going to have enhancement of this, right? We're going to have an enhancement of this code. It's an
Yeah,
ongoing
go
project.
ahead, Ate. Only go ahead. Ate, go ahead with your question, please.
Can you please give me permission to share my screen?
Okay, a minute, please. Let me just execute this. A minute, please.
You can share your screen. It's enabled.
Okay, let me stop sharing. So go ahead. Okay. So I've just shared the code.
Can you
Anyone
see
who
my
had
screen?
that error. Yeah, I can. Anyone who had that error, I just reshared the code. On the chat. Okay, so we can see your screen. What's the problem? Let's see how we can help you. Okay, so now I think that was what I was trying to troubleshoot. So use this code I just dropped now on the chat. Take off that code you have on your NAT gateway and use the one I just dropped now, and that error will be resolved. So you could now do a plan, Terraform plan, and a Terraform apply. You should be fine. Yes, Samuel, please go ahead.
Okay, I equally think check the code you had. The person sharing, there is you missed out a .id, right? You see, line 2, you had public subnet 1. You never inserted .id at the end. You can see your error message down on your Git bash.
Yes, Doc. If she copies that carries everything, and she'll be
exactly.
fine.
Exactly.
Please, what do you mean? Can you hear me, please?
Yeah, we can hear you.
What do you mean by 3-tier architecture?
Okay, so Doc, would you want to respond to that?
Okay, all right. So give me 1 second while I display this, so you can have a clear picture of what a 3-tier architecture is all about. Now, in creating an application design, we want to look for best practices in such a way that we are able to provision our application by creating different layers. And what are some of the key layers of every application? Well, at the forefront, we have a layer called the web, right, which is kind of the presentation layer that we want our end users to be able to have access to. And so that presentation layer is actually displayed on what we call the web tier, right? And that web tier, I want to bring an image here so you're able to have a picture of what I'm trying to say. So right here, let me share my screen. So the first layer of the application is kind of like the presentation tier. And you want your end users to be able to see your application. Just like, for example, you go to a website, see solarvistech.com, right? So this is the first layer. And like, let's say, for example, here, we could host that web tier here with web servers in a public subnet, as well as we could also host it in a private subnet. Now, the next layer or the next tier, or right equally in this first tier, we could also have other resources like a NAT gateway, could have like a front-end load balancer, because those are resources that would receive traffic directly from the internet. Now, we want to also break that application into a second layer, which is going to process the logic, which means, for example, you want to log into a website, say Amazon.com. It's going to request for your username and your password. Once you input all of that, the logic in the back end is going to be processed by a second layer, which is called the web tier, or we call it, the app tier, right? And that app tier probably want to put it in what we call a private subnet, which the end user should not have direct access to, right? For security reasons as well. Then whatever you're going to insert on your front end, let's say you're using on a password, the system is supposed to check to see if those credentials you're going to insert actually matches with what is actually saved in the company's backend or the application backend. And that backend here is your database tier. So the third layer or the third tier here is the backend where you actually have your database residing. So previously, what used to happen without this application modernization, companies used to create all the application hosted in one stack. So in one EC2 instance, you have the web tier, you have the app tier, you have the database tier. But what happens if you want to make improvement on just one layer? It therefore means you have to put down the entire application. So a 3-tier architecture here helps you to separate those different layers so that if you want to improve or optimize or improve on security, whatever, on a specific layer based on the need, you can go to just that specific layer and you can be able to apply those improvements. Also, you are able to scale each layer independently. At the same time, you're able to apply security measures around individual layers. And you being able to increase the number of layers of security also gives a lot of headache, to say adversaries who want to attack your application, right? So it helps improve on your application. So this is what we mean by a 3-tier architecture. We could still go ahead to make it what we call a 4-tier, right? Which means that things like the load balancer, the NAT gateway, right? We could put them all in the public, and then our web tier remains in the private. The app server remains in the private, and then the database layer remains in the private. So we actually have those 4 tiers. So it's just a way of structuring our workload. I hope that makes some sense.
Yes, if I understand you well, the web server layer, okay, it can be the front end of the application. Then the app server would be the back end of the application.
Right.
Okay.
That's
okay.
it.
Then
And then, the third layer is a database.
Okay.
Exactly.
Okay. I get you.
Cool. Perfect. Perfect. So, Doc, would you want to?
Yes. So I think we've come to the a logical end of this session. And guys, I'd really want to appreciate you all. We are still 30 on the call up till now. This just reflects the fact that you guys got a lot of value from this session. And if we did get a lot of value, I want to promise you guys that we're going to have a recording of this session. As soon as it's processed, we would share it. And so those who are not yet in the group, please, I'm going to share again on the chat. Now, once it's made available, kindly, share your learnings on LinkedIn. You're going to share your learnings on LinkedIn. And as you share your learnings on LinkedIn, please kindly tag us. Tag Solavis Technologies Institute. Appreciate the trainers, Misan as well as Eddie. And then you can equally tag myself. All right. Let's create more awareness of what we're doing. There are a lot of people who would have wished they were in this session today, but then we're going to have subsequent sessions. So, and if you have any other suggestions for us, please don't hesitate. You can reach out to me on LinkedIn, and let's see how we can improve on our journey. I look forward to us this 2024 celebrating, many more people getting jobs in the industry. And yeah, that's the kind of energy we want to celebrate in 2024. So thank you all once again. And I think at this point in time, let's get
Doc, we have to hold on. So before the feedbacks, we have to collectively destroy our resources so no one is being charged.
Right.
So guys, please at this moment, let's all go back to our VS Code and kindly do the Terraform destroy command so we don't have our resources running when we don't need them. Because if we do, at the end of the day, we could now get charged. I don't want to be held responsible for having to incur some unwanted bills. So let's go and do the Terraform destroy command and be sure we get the destroy completed prompt before we eventually leave.
Yes, please, Stephen, we're going to have a GitHub repo for this work we're doing. So we will be able to share equally the GitHub repo, so everybody can be able to have access to it. You can clone it, you can improve on it. So we can equally be working on the code, right? Even before our next session. So keep your eyes on updates. You can work on the code, you can equally enhance it on your end, right? Before the day we're going to meet. Thank you very much, Stephen.
Prof, quick question. How do we push this if we want to have it in our GitHub repository, like something like build a profile? How do we push this to GitHub?
All right, so Misan, you want to take that, right? Okay.
So I wanted to say we're going to eventually get to that point, but I didn't want it. So you respond to that, Prof.
Yes. So let's collectively agree, right? Guys, this work from home. My son is here. Okay, come greet my people. Greet everyone. All right. So let's agree. Should we spend a little more time to be able to create to push this our GitHubs? That would be amazing for our individual
Well, I'll take permission to leave Dr. Samba.
Because of the timing, right?
Yes, I need to run along, and
I think so too.
Yeah.
I
We
think
can
so.
see when next we meet for the next project. So.
Definitely we will do that.
Okay.
We will do that. All right,
Okay.
guys. Any feedbacks, 2-3 feedbacks would be great. And mind you, in less than 24 hours, the processed recording will be made available for everyone to have access to. Thank you for the feedback.
Thanks, guys.
Thank you. Thanks, Misan. Thanks. We appreciate you. Okay, without much ado, you can kindly unmute yourselves and say goodbye to everyone.
Thank you,
All
Samba.
right.
Thank you,
Thanks for
Bye.
your sacrifice.
Thank you very much.
I appreciate it.
Goodbye. all.
Bye.
Yeah, goodbye.
See you next time.
Thank you. Thank you, everyone.
Yeah, goodbye.